I'll be solving a problem on knuckle joint. So the problem is design a knuckle joint to transmit 150 kilonewtons. The ultimate stresses or yield stress for rods and pins are 400 megapascals, 360 megapascals, 900 megapascals in tension, shear and crushing, okay, respectively. So assume a factor of safety of 6. So they are given the factor of safety and yield or ultimate load they have given. So initially we will note down the data. So this is ultimate tensile stress, ultimate shear, ultimate crushing. That's why I have used U term here. If it is yield, you can use it as Y also or U also. Fine. So factor of safety is 6. So we will note down the permissible stresses first. For that, what we have to do is ultimate or yield stress divided by factor of safety. That will give you the permissible stresses. It's a tensile, shear and crushing. So 1 megapascal is equal to 1 newtons per meter square. 1 megapascals is equal to 1 newtons per millimeter square. So let's start with the solution part. Design of rod and rod end. See, in data handbook, if you remember the step, you can write this simply, or in data handbook we will be having, see here, this is the third edition data handbook. So here we have tearing resistance of a rod. That is this equation in data handbook third edition is 4.34. So 4.34 in third edition, and the page number is 57, and in fourth edition it is 4.19a equation in fourth edition. So equation is P is equal to pi by 4 d square into sigma t, that is working or permissible. What we have to use is permissible. Once we have to convert all this ultimate or yield stresses into permissible, and after getting this, during the calculation we have to use permissible only. If we use ultimate, then the problem or ultimate or yield, the problem will go wrong, the solution is negative or wrong. So we have to use permissible. So initially we have to calculate the diameter. So substitute the value and get the diameter. D is equal to 50.46 millimeter. So therefore the standard diameter, what we have to consider is next even number. After 50.46, the next even number is 52. That is the way how we will assume the standard diameter for knuckle joint. So 52 millimeters. So diameter of the rod end, here you can see in the sketch, that is page number 59 in third edition. What you can see is here, you see D is the diameter given in the data handbook. This image is there in your data handbook. So D is the diameter and D1 is here, D1. So D is equal to D1, what we consider every time. Here also, here they have given properties used in practice. So these are the properties. See, properties used. So we have to calculate this one using the diameter value. Here is the equation. So F, C, A, B, C, D, E, F, G, A, B, C, or D, E, F, G. These things are sufficient if you note down, or you can mark down or calculate full table and answer. We have answers here. Okay. So here are the values. So we'll go to the second step, design of knuckle pin. That is equation is here 4.36 third edition, fourth edition. So here see this the design of knuckle pin, or you can write this also, resistance to shearing of pin. It is P is equal to pi by 4 d1 square tau into 2, 4.36 equation. Okay. So you can write this design of knuckle pin, or this as well, the resistance to shearing of the pin. So you have to check tau value, we have to calculate, so that if it lies below this permissible value, okay, that you have to calculate. And next step is design of eye end. So in this design of eye end, see here you can see the eye end. see single eye is, this is eye end, here it contains a hole, through hole, here to here it's a through hole, this will be inserted into this portion. So you have to calculate this, you have to design of eye end. Now you are designing this one. The equation is here, third one, the tearing resistance of the section across the eye end and along a plane through the pin axis, that is P is equal to F into D minus D1 into sigma T, that is tensile. So here you have to calculate tensile stress, shear stress and crushing stress also. So all three you have to calculate. For this tensile and shear, this what the only difference is the sigma t has to be replaced as tau during the shear stress calculation. So remaining everything is same, this you have to replace to tau. So calculate, so you have to calculate sigma t, that is tensile here, and tau here, that is shear. What we have to confirm is this value, this is the calculated value or design value, and this is the permissible or allowed value, working value. Okay, so this the values whichever it is given, it should, this value, these values must be less than these values, that is permissible value. So this same as shear, so you'll get 36.98, and same here. And for crushing, the equation is F is P is equal to F into D1 into sigma C, that is sigma crushing. Equation 4.41 in third edition data handbook. So you will get the value, this one. See here you can observe this value, sigma C value and tau value and sigma T value are same. Okay, so these are all same values, and this is one set of value for design of eye end. Okay, and here during the design of fork end, you can see here in the sketch, this is fork end, this portion is fork end, this is eye end. Okay, this is fork end. So here in fork end, same a tensile, shear and crushing you have to calculate, similar to the eye end. Okay, here also you have calculated same tensile, shear and crushing, same in forked end also, tensile, shear and crushing, but equations varies. So here for tensile, this is the equation 4.39, same, replace sigma t to tau during the shear stress calculation, and for crushing stress the equation is this one. Okay, equation is 4.42 third edition, in fourth edition 4.21. So the difference in eye end and forked end, only difference, see this value, shear, tensile and crushing value, and this the forked and shear, tensile and crushing value, either it may be same all 36.98, or one set of value, three values, one set of eye end, three values, shear, tensile, crushing, and one set of three values for in forked end will be same, or whole entire values will be same. Okay, entire values of forked end and eye end will be same, or forked end one set value and eye end one set value will be same. Okay, by that way you can understand that your solution is clear and correct. Okay, at the end what you have to write is, this is very much important. From the above, this is the above calculation, we see that the induced stresses are less than the given stresses. Induced means what you have calculated, these stresses are less than the given stresses. These are the given stresses. Therefore the joint is safe. This comment you have to write at the end of the solution, entire solution. Okay, so these notations which we have calculated are here, CF, B, E, D1, D, okay, A, H, everything it contains. You can observe here, this is the top view. Okay, thank you.